February 12, 1943, outside Kharkov, Ukraine. The Panzer IV sat motionless in frozen mud, its 30 tons sinking deeper with each failed attempt to move. The crew had abandoned it hours ago, leaving only the cold wind and the distant rumble of Soviet artillery. Then, through the snow, came a sound like rolling thunder, low, mechanical, relentless. The Famo was coming. Before we go further, if you're finding value in these deep dives into the machines that shaped history, hit that like button and subscribe to the channel. Drop a comment and tell us where you're watching from, whether it's Berlin, Boston, or anywhere between. Your support keeps these untold stories alive. The half-track moved like a beast of industrial myth, 18 tons of German engineering crowned by a Maybach WW2 that refused to acknowledge the impossible. Its crew worked in silence, mechanical priests performing a ritual of recovery. Steel cable unwound from the massive winch, drawn taut across the frozen ground, and the Famo began to pull. The Panzer IV, entombed in ice and earth, shuddered. Then it moved. In that moment, watching a machine drag another machine from death, the crew understood a truth the High Command would never admit. Germany wasn't winning this war with superior tanks or brilliant tactics. It was buying time with vehicles that refused to let the war machine stop moving. And the Famo was the heart that kept that machine beating. In the late 1930s, Germany faced a problem disguised as progress. The new Wehrmacht was building tanks faster than it could support them. Armored divisions raced across doctrine papers and proving grounds, but no one had solved the question that would define modern warfare. What happens when a 40-ton Panzer breaks down 200 miles from the nearest railhead? The answer couldn't be horses. By 1938, Germany still relied on over 600,000 horses for logistics, more than Napoleon had used. But horses couldn't drag disabled tanks. They couldn't tow the massive 24 centimeters K3 railway guns that weighed over 80 tons. They couldn't project the image of a mechanized future while collapsing under loads their ancestors had carried for centuries. The Heereswaffenamt, the Army Weapons Agency, issued a requirement that bordered on fantasy. They wanted an 18-ton prime mover capable of towing 40 tons across any terrain Europe could offer. It needed to operate in Russian winters and North African summers. It needed to recover tanks under fire and haul bridging equipment across rivers that no longer had bridges. And it needed to do all this reliably, repeatedly, without the industrial support system that peacetime engineering took for granted. Several firms studied the brief with the careful attention engineers reserve for impossible problems. But one company in Breslau had been preparing for this moment for years. Fahrzeug- und Motorenbau GmbH, known simply as Famo, had built its reputation on heavy industrial engines and experimental half-tracks. Their factory floor spoke the language of rivets and torque, where problems were solved in steel rather than words. The chief engineer at AEMA, a man named Becker, whose notes survived the war in marginal annotations, understood that the solution wasn't simply scaling up existing designs. The half-track they needed required a fundamental rethinking of how weight, power, and traction could coexist. He sketched chassis configurations that stretched over 9 meters, suspension systems with 12 overlapping road wheels per side, and drive trains that could transmit 270 horsepower without tearing themselves apart. By 1936, the design that would become the Sd.Kfz 9 existed on paper, a vehicle so large it made other half-tracks look like toys. The Maybach HL 108 engine alone weighed nearly half a ton. The transmission required gears hardened beyond standard specifications. The chassis had to flex without fracturing, supporting 18 tons while distributing force across tracks and wheels in perfect mechanical harmony. Testing began on proving grounds where other vehicles had failed spectacularly. Early prototypes cracked frames and burned clutches. Each failure generated pages of technical notes, adjustments measured in millimeters, alloy compositions refined by single percentage points. German engineering culture treated failure as data rather than defeat, and the data accumulated until the machine worked. Then came the moment that validated everything. In a demonstration for Wehrmacht procurement officers, a prototype Famo hauled a captured French Char B-1 tank 32 tons of dead weight across a muddy field without hesitation. The officers watched in silence as the half-track's tracks bit into earth that would have swallowed wheeled vehicles. When the demonstration ended, orders were signed without discussion. Germany had found its answer. They called it the Famo, after the company that built it. But to the crews who would later depend on it, the vehicle earned simpler names. Der Unermüdlich, the tireless one. Der Bergretter, the mountain rescuer. The machine that refused to quit. The Famo factory in Breslau operated with the precision of a watchmaker and the scale of a shipyard. Production lines stretched across halls where sparks fell like rain, and the air smelled of hot metal and cutting oil. Every Famo began as raw steel plates and ended as something that looked less like a vehicle and more like a moving fortress. The Maybach HL-108 engine came first, installed by crews who treated it with the reverence mechanics reserved for complicated things that must work perfectly. 12 cylinders arranged in a perfect V, producing 270 horsepower at 3,000 revolutions per minute. The sound of a Famo engine starting wasn't a roar. It was a low, patient growl that suggested unstoppable momentum rather than speed. The transmission followed, a Maybach Varior X semi-automatic gearbox that weighed 500 kilograms and required 4 men to install. Inside its hardened steel casing, ears mached with tolerances measured in hundredths of millimeters. This was where the Famo's pulling power originated, not just in horsepower, but in the mechanical advantage of ratios that multiplied torque until the impossible became merely difficult. The chassis told its own story. 9 meters long, constructed from steel plates bolted rather than welded, so field repairs could be made with basic tools. Along each side, 6 Schachtaler fork bogies interlaced their road wheels in overlapping patterns that distributed weight so effectively the Famo exerted less ground pressure than a man standing. This was the secret to its mobility, not fighting the terrain, but spreading across it. Assembly workers installed the winch last, mounting it behind the crew cabin like a mechanical heart. The drum could hold 200 meters of steel cable, each strand thick as a man's thumb. The winch was driven directly from the gearbox through a power takeoff system that could generate 15 tons of pulling force. Recovery crews later described the sound of the Famo's winch as industrial thunder, the voice of a machine that moved mountains by choice rather than accident. Quality control bordered on obsession. Each completed vehicle underwent factory trials that lasted days. Engines ran for 48 hours straight, while technicians monitored temperature, oil pressure, and the subtle vibrations that indicated problems invisible to the eye. Suspensions were tested on simulated terrain that replicated everything from Belgian mud to Russian snow. Braking distances were measured to the meter. Nothing left Breslau unless it had proven itself. By 1940, production had reached full tempo. The factory operated in shifts that blurred into continuous motion, workers moving between stations in practiced rhythm. Skilled engineers worked alongside conscripted labor and, increasingly, Workers from occupied territories whose names appeared in production logs but never in company photographs. The Famo emerged from this system, each vehicle carrying within it the contradictions of an industrial power built partly on coercion. Photographs from the period show completed FAMOs lined in rows, their massive half-tracks gleaming under factory lights. They looked ready for anything, and across Europe, from the forests of France to the steppes of Russia, they would get their chance to prove it. The Famo entered the war quietly, rolling into Poland in 1939 as part of recovery columns that followed the panzer divisions. Its first real test wasn't combat, it was the aftermath, the brutal calculus of maintenance that determined whether mechanized warfare could sustain itself beyond the first breakthrough. In France, 1940, the Famo proved its worth in ways that never made the newsreels. When panzers bogged down crossing the Meuse, VMOs hauled them free. When bridges collapsed under the weight of German armor, FAMOs towed pontoon sections into place. They operated in the gaps between glory and logistics, the unglamorous spaces where wars are actually won or lost. Russia changed everything. The Eastern Front devoured machines with an appetite that stunned even German planners. Tanks broke down in numbers that overwhelmed repair capacity. Artillery pieces sank into mud that swallowed them to the axles. And the Famo became more than a recovery vehicle. It became the difference between mobility and paralysis. Oberfeldwebel Hans Kruger, a recovery platoon commander, kept a diary that survived in fragments. His entries from the winter of 1941 describe cold so severe that steel became brittle, fuel froze in mines, and men could barely hold tools. Yet the FAMOs kept working. Their Maybach engines, designed for precision, ran on whatever fuel could be found. Their hydraulic systems, theoretically vulnerable to cold, were serviced in temperatures that defeated lesser machines. Near Smolensk, Krieger's unit recovered a Tiger I tank 56 tons that had thrown a track in a drainage ditch. The operation took 2 FAMOs working in tandem, their cables interconnected, both engines roaring as they pulled in synchronized effort. The Tiger emerged slowly, grudgingly, like a beast dragged from sleep. When it was done, Kruger wrote simply, "The machine does not complain. It only works." In North Africa, the Famo confronted a different enemy. Heat that could cook eggs on engine blocks. Sand that infiltrated every seal and bearing. Supply lines stretched across hundreds of miles of desert, where a single breakdown could mean death. Recovery crews removed side panels to increase airflow, fitted improvised filters to carburetors, and learned to work through sandstorms that reduced visibility to arm's length. At El Alamein, Famos recovered not only German tanks but captured British armor, towing them back to workshops where they would be repaired and turned against their former owners. The half-track's utility transcended nationality. It simply moved what needed moving, a mechanical mercenary loyal only to the physics of traction and torque. By 1943, the Famo had earned a reputation that bordered on mythical. Crews spoke of vehicles that had been recovered 3, 4, 5 times, each time hauled from destruction by the same patient half-tracks. There was a cruel mathematics to it. A Tiger tank cost 250,000 Reichsmarks in 6 months to build. A FAO cost 80,000 and could save a dozen Tigers in its service life. In purely economic terms, every Famo was worth its weight in armor. But economics couldn't capture what the vehicle meant to the men who relied on it. To a tank crew stranded behind enemy lines, the sound of a FAMO's engine was the difference between capture and survival. To mechanics working in frozen fields, it was the tool that made impossible repairs merely difficult. To commanders watching their armored strength evaporate, It was a small defiance against the arithmetic of attrition. The Famo didn't win battles. It recovered the machines that fought them, then recovered them again, sustaining a war machine that should have collapsed under its own weight. In that recovery, in that relentless refusal to let steel stay broken, lay something profound, a machine built not for destruction, but for preservation, serving a cause that understood neither. By 1944, the Famo had become Germany's most essential vehicle at precisely the moment it became most vulnerable. Allied air superiority meant recovery operations happened under constant threat of attack. Fuel shortages forced crews to operate on strict rationing, measuring every kilometer against dwindling reserves. And the industrial capacity that had built the Famo was dying under bombs that fell with increasing precision. Production at Breslau struggled under conditions that would have stopped peacetime manufacturing entirely. Raw material shortages meant substituting lower-grade steel for components designed around specific alloys. Copper became so scarce that electrical systems were rewired with aluminum, which conducted poorly and overheated frequently. Rubber for seals and gaskets disappeared, replaced by synthetic compounds that cracked in cold and melted in heat. The workforce changed, too. Skilled German workers were conscripted to the front, replaced by forced laborers from occupied territories. Polish workers assembled engines alongside prisoners from France, supervised by engineers too old or too valuable to fight. The factory that had once embodied precision now ran on desperation, each completed vehicle a small miracle of improvisation. Yet Famos continued to roll off the lines, their specifications compromised, but their essential character intact. Field reports noted the decline clutches that wore faster, transmissions that required more frequent maintenance, engines that no longer tolerated poor fuel. But they also noted that even degraded, the Famo remained more capable than any Allied equivalent. German engineering's margin of excellence had been so great that even diminished, it still exceeded the requirements. The final year of war saw Famos performing tasks their designers never imagined. They hauled refugee columns out of collapsing pockets. They towed damaged aircraft from cratered runways. They pulled supply wagons when trucks broke down and trains couldn't run. The vehicle built to sustain mechanized warfare became instead a testament to endurance continuing to function as the nation around it dissolved. In the ruins of Berlin, April 1945, one of the last operational Famos was photographed towing a disabled Panther tank through streets choked with rubble. The half-track's paint was gone, replaced by rust and impact scars. Its crew looked more like ghosts than soldiers, but the machine moved, cable taut, engine running, performing its function long after function had ceased to matter. This was the Famo's final irony. Built as an instrument of conquest, it became instead a symbol of terminal stubbornness, the German capacity to engineer excellence even in service of failure. The machine had done everything asked of it. The cause it served had asked for the impossible. When the war ended, the Allies discovered Famos scattered across Europe like monuments to a mechanical faith. Some sat abandoned in forests, their fuel tanks empty, their crews fled. Others were found still operational, maintained by soldiers who had nothing left to fight for, but refused to let their machines die. The British recovered several intact examples and immediately put them to work. Recovery units in the occupation zones used Famos to clear destroyed armor from battlefields, the half-tracks towing away the evidence of their own side's victories. Soviet forces did the same, repainting captured Famos with Cyrillic markings and folding them into Red Army service. The machine's utility transcended ideology. It simply worked. And in the chaos of post-war Europe, Working machines were more valuable than political purity. One Famo, recovered by British forces in 1945, eventually reached the Bovington Tank Museum. Restored over decades by volunteers who treated each bolt as archaeology, it now sits under soft lights, its Maybach engine silent but complete. Visitors walk around it, dwarfed by its scale, touching steel that once pulled tons across frozen battlefields. The machine asks nothing. It simply exists, proof of what precision and discipline could achieve. In France and Belgium, a handful of Famos survived in private collections, maintained by enthusiasts who understood their historical significance. Starting one after decades of silence required patience, skill, and parts salvaged from wrecks scattered across the continent. But when the engines turned over, the sound was unmistakable, that low, patient growl that had once meant salvation to stranded crews. The FAMO's design influenced post-war engineering in ways that were never officially acknowledged. Soviet heavy tractors borrowed its load distribution principles. American recovery vehicles adopted variations of its winch systems. British engineers studying captured examples noted the redundant construction, the accessible maintenance points, the way every component was designed to be repaired rather than replaced. These lessons filtered into doctrine, shaping how modern armies thought about vehicle recovery. Perhaps the Stranist legacy was emotional? Soldiers who had served with Famos spoke of them with something approaching affection, a sentiment rarely directed at military equipment. They remembered machines that worked when nothing else would, that pulled friends from situations that should have been fatal, that represented reliability in a war defined by chaos. The Famo hadn't saved Germany, but it had saved individual lives, and those lives remembered. Time has reduced the Famo to museum pieces and memories, but what it represented remains. In halls where historians walk and children stare, the half-track sits as evidence of a peculiar truth, that engineering excellence can exist within moral failure, that machines can be perfected even when the causes they serve are corrupt. The Famo was built by a regime that measured worth in conquest and wrote doctrine in blood. Yet the vehicle itself embodied virtues, discipline, precision, reliability, that transcend the purposes they served. The engineers who designed it weren't building monuments to ideology. They were solving problems of torque and traction, answering questions about how metal could move through mud. The Famo endures not for the swastikas once painted on its flanks, but for the engineering that still turns in museum basements. Built for war, it later helped rebuild cities, its winch clearing rubble and its Maybach engine inspiring civilian machines. The crews who drove it remembered a reliable, tireless tool stripped of ideology, defined only by function. Today it stands silent under museum lights, its power tamed by time. No longer tearing frozen earth or hauling tanks, it instead preserves a lasting truth, that human ingenuity outlives the purposes of war, proving excellence in craft can survive its origins.